Today we are going to learn how to do linear interpolation. So, what is interpolation? So, if we have two random variables, we have their x and their y, generally from a table of some sort. So we have x1, x2, y1, y2. And then we have some other value that's in between them. And we have either the x component or the y component. We can use linear interpolation to figure out the other one. If we have x3, we turn this into a line, and we can find y3. So let's figure out how we do this. Our goal is y3. So we're going to use these values on the graph here to try and figure out what is going on. So the first thing is we're going to notice this distance here. This is how far along we are. And here is the total distance. So we're going to start with how far along we are out of the total distance. So that is x3 minus x1. That's this distance here. And then the total distance is x2 minus x1. This total distance. So we say x3 minus x1 over x2 minus x1. That is the percent along we are. So if this was 1, 2, and 3, and we're at 2, well, then x2 is 3, x1 is 1, x3 is 2, and x1 is 1. So that is 2 minus 1, 1, 3 over 1, 2, 3 minus 1, 2. We are halfway along. So that's the first step, is figuring out how far along we are. Then we need to do the same thing for the y. So we are going to look at how far along the y we are. We've already calculated the percent total, so now we just need how far along the y we are. The total change in y, if we have some percent along the x, then we multiply that by the total change in y, and that is the percent along the y, which is what we're solving for. So then we just multiply this by y2 minus y1. So we have the percent along the x. We multiply the percent along the x by the change in y, and that becomes the percent along the y. To get the final y value, though, you have to add to the initial y. So that's just y1. And that is the interpolation formula. If you really wanted to, you can rearrange this in terms of slope. So we say now y3 is the slope, y2 minus y1 over x2 minus x1 times x3 minus x1 plus y1. And this is just the definition of slope. So if you calculate the slope and then you multiply that by the change in x and add it to the initial y, you can find our final y point. So now this is our formula. So let's use this to solve a problem that you might see in engineering. In classes where there's a lot of hard integrals, or data is determined through just experimental data, often seen in thermodynamics or heat transfer, you'll be given tables. So if you know some values, then we can use linear interpolation to get a good estimate of the value. So let's say we have the density, we have a temperature 20 and 40. And our goal, we're given in our question that the temperature we want to look at is 33 degrees. And what variable do we want from this? We want the Prandtl number. So then 33 degrees, and we want to look at the Prandtl number. So we look at the two, 20 and 40, and the Prandtl number for those. So let's just write everything down that we know. So the T we want is 33 degrees C. We say T1 is 20, T2 is 40. Then associated with 20, the Prandtl number, PR, is 10863. The Prandtl number associated with 40 is 2962. So this is PR1, PR2. Now we can just substitute numbers into this formula. So we have Y3, and in this case, Y is our Prandtl number. So PR3 is equal to Y2 minus Y1. So that's 2962 minus 10863. X2 minus X1. So X2 is T2, so that's 40 minus 20. Then we multiply that with the distance along the X. So this is T3. So we say 33 minus X1, that's T1, 20. Then we add that to our initial Y, which was our Prandtl number 1. 10863. So then we can type all of this into our calculator. So we first be very careful with the parentheses here. So we're going to subtract the top two first. Focus on this. So the subtraction of those is -7901. 40 minus 20, that's 20. Then we multiply that by 33 minus 20, that is 13, plus 10863. Again, be very careful with the parentheses, because it can lead to some wildly wrong answers if you don't pay attention to your parentheses. But then we get that the Prandtl number 5727.35 is PR3. Now, let's double check to make sure this makes sense. So we're a little bit above, we are a little bit above 30, a little bit above halfway. So we should expect this to be about halfway between these two values here. So between 10 and 3, almost 11, 11 and 3, about 6,000 makes sense. So this number should make sense.